Hello children, welcome to your online physics class. In the previous lecture, I discussed about carbon resistor, color code of carbon resistor. I also explained how to find the value of a carbon resistor available in the market on the basis of its color coding. Today, I am going to start with electric cell. Okay, so electric cell. Electric cell. Electric cell. You all have learnt about electric cell. You studied about electric cell in class 10 also. So can you recall an electric cell? Yes, you can recall an electric cell as the source of energy. Okay, as the source of energy which motivates, which compels free electrons to move in a fixed direction and constitute an electric current. No, an electric current. So electric cell is a device which provides energy. Now, how does it produce energy? Actually, an electric cell converts chemical energy into electrical energy. Okay, so you can also say that an electric cell is a device which converts chemical energy into electrical energy. So one thing is clear, that electric cell is the source of energy. Okay, you have the idea about its symbol. It has two vertical lines. One line is longer than the other line. This longer line is said to be positive terminal and the shorter line is said to be negative terminal of the cell. So this is the idea about, this is the brief description of an electric cell. Now I will study about different terms related to electric cell. First term related to electric cell is EMF. EMF, which is called electromotive force. Electromotive force. You can get confused that electromotive force, here a word force is written, so you don't take it otherwise that force means force. Okay, this force doesn't mean force whose unit is Newton. Okay, this is the energy only. It is said to be force as it motivates free electrons to move along a fixed direction. Is it clear? Now actually EMF is the electromotive force, is the potential difference between the two terminals of a cell. Terminals means positive and negative terminals, which are called electrodes. You also learnt all these things in chemistry. Okay, so it is the potential difference between two terminals of an electric cell in an open circuit. Open circuit means when switch is off, circuit is said to be an open circuit. When switch is on, then the circuit is said to be a closed circuit. Okay, so in an open circuit, current is not drawn from the cell. Is it clear? Means cell is not in function. Okay, so when cell is not functioning, then whatever is the potential difference between its two terminals, that is positive and negative electrodes, is called electromotive force, and it is denoted by E. Electromotive force is denoted by E. If you start writing EMF, okay, means if sentence starts with electromotive force, then you should write EMF in capital. If you write EMF in between two words, then you have to write this EMF as a small e, small m and a small f. Okay, so this is the symbol to represent electromotive force. As it is potential difference, so what is its SI unit? Its SI unit is volt, which is denoted by capital V. Got it? Let us explain it with the help of the diagram. Suppose this is a resistor. Its resistance is R, and this is connected to an electric cell. This is the key. Switch is off, and if you will connect a voltmeter here, whatever its value is, that is called EMF, electromotive force. Got it? So what is electromotive force? EMF, it is the potential difference between two terminals of an electric cell in an open circuit. One thing should be clear to you, that this is the maximum potential difference between the two terminals of the cell. Whenever we will switch on the circuit, then potential difference reduces. Okay, so I am going to discuss that now, and that is called terminal potential difference. Terminal potential difference. Terminal potential difference. Okay, so this is terminal potential difference. Terminal potential difference is denoted by V, and its SI unit is also volt. But it is the potential difference between the two terminals of the cell in a closed circuit. Got it? Means both, whether it is terminal potential difference or it is electromotive force, they are potential difference between the electrodes of an electric cell. The difference is that terminal potential difference is taken in a closed circuit and EMF is taken in an open circuit. One more thing should be clear here, that terminal potential difference is less than EMF of the cell. Whatever is printed on an electric cell, that is the value of its EMF. Got it? Suppose this is a circuit. Resistance offered is R, and this is connected to a cell. This is the key. You switched on the key and connect a voltmeter across the cell. Whatever will be the potential difference, that is called terminal potential difference. Means this is V when switch is on and this is E when switch is off. Now I will find the relationship between terminal potential difference and EMF, and before going to derive that relationship, I want to introduce a new term, that is internal resistance of an electric cell. So let us discuss about that. Internal resistance. Actually, this is the resistance, means obstruction, offered by internal components of an electric cell. Do you think that what are the internal components of an electric cell? I think you learnt about these terms in chemistry, that electric cell has electrodes. One is called anode and another is called cathode. Electric cell has electrolytes. Okay, so these are the components of electric cell. Okay, and they are internally fixed inside a container. So resistance offered by these components, that is electrodes, electrolytes, to the flow of electric current, is called internal resistance. And internal resistance is denoted by small r. Suppose here is an external resistance R. External resistance means a resistance offered by an electrical component in the circuit, and here is an electric cell. EMF of this electric cell is E, and internal resistance is represented like this. It is denoted by a small r. Okay, circuit is switched on, already switched on. So a current is flowing through the circuit. Suppose the current is I. Got it? So this is the internal resistance. Now there are some factors which affects internal resistance. So factors affecting internal resistances are nature of the electrodes, size of the electrode means area of the electrode inside the immersed in the electrolyte, nature of the electrolyte, concentration of the electrolyte, distance between two electrodes. So all these affect internal resistance of an electric cell. Got it? Now let us define the relationship between E, V and R. So from this circuit diagram you can see that the resistance in the circuit is this R and this R, and they are connected in series. Okay, so total resistance offered by the circuit is R plus R. Here capital R is the external resistance and small r is the, capital R is the external resistance and small r is the internal resistance. And current through the circuit is I. So I into R. This is the potential difference across the cell, and that is called EMF. So E is equal to I R plus R. Got it? You can write it IR plus IR. You see this IR is terminal potential difference V plus IR, and this I into a small r is the difference in potential of the two terminals of the cell caused due to the internal resistance. So this IR is called potential drop across the cell. Potential drop across the cell. Got it? It is called potential drop across the cell. So you can observe that EMF of the cell is equal to terminal potential difference of the cell plus potential drop across the cell. What does it mean? It means EMF is greater than V, and difference of E and V is equal to IR. And from here you can find the value of internal resistance as R is equal to, small r is equal to E minus V by I. Got it? So this is the formula for internal resistance. You can also write it as R is equal to E minus V by I. You see E by I minus V by I. You know V by I is equal to R, so you can write E by I minus R. This can also be the relationship for small r. Okay. So you got the expression for small r here? No. Now I want to explain the graphical relationship between E and R. So first, graphical relation between E and R. If you will take R along x-axis and E along y-axis, the graph is a straight line. The graph is a straight line. This is the graphical relation between E and R. Means the value of EMF is independent of external resistance R. Got it? Graphical relation between V and R. V and R. You see. Take R along x-axis and V along y-axis. The graph is like this. This is called E. Okay, means potential difference increases with increase in external resistance. Potential difference increases with increase in external resistance. Got it? And it becomes maximum whenever it becomes equal to E. And third graph is, this is second one, graphical relation between V and I. This is I and this is V. This is O. This is called E and this is called E by R. Okay, so these three are the graphical relations between E and R, between V and R, and between V and I. In board examinations, you can be asked to draw a graph related to this. Means any one of the graphs can be asked and it will be of 2 marks with description and 1 mark without description. Okay, so this is the EMF, internal resistance and terminal potential difference related lecture. In the next lecture, I will start with Kirchhoff's law, and after learning Kirchhoff's law, I will start with applications of Kirchhoff's law, and then we will learn grouping of cells and all. Thank you.